Today we are going to be covering 10.4, which is our last lesson in chapter 10. So in 10.4, we're going to be talking about an inverse of a function. So probably the first thing we really need to talk about is what is an inverse and how does it work, okay? So first, an inverse really is just something that switches, or sometimes I like to think of it as it undoes an operation. So for example, if you had an operation where you had 10 is equal to x plus 5. To get this x alone, you have to undo this symbol. And the only way to undo it is to do the opposite, which is a minus. So then you would subtract the 5 from the other side as well. So really, this step right here, this step of getting these to cancel is really what an inverse is all about. I mean, that's the basic idea of an inverse. You can also think of an inverse like directions. So let's say we were at the high school. Okay, so we're at the high school and, we leave the high school and we turn right. So we're turning right and we're going down 32nd and we cross that light and then there's McDonald's right here. Well, we would have to turn left to go into McDonald's. So we went right and then we went left. Well, now let's say we've gotten our food at McDonald's and now we need to go back to the school. So we would leave McDonald's and we would turn right. So we would be facing this direction. So we would turn right, we would travel down, and then when we get to the drive, we would turn into the high school, but we would turn left. So we would turn right and then left. Do you see how these are the opposite of each other? Do you see how right, left, right? See how they're the opposite, okay? So this is essentially what an inverse does. Some people also call this reverse. So some people say it reverses things, okay? Now, there's two different types of examples that you have to worry about today. They're just going to give you some type of relation. Now, we're not worried about what kind of relation this is. It could be linear, it could be exponential. We don't really care. We just need to know that it's a relation. So just there's some graph. And then down here, they're giving us a linear line, and they want us to find the inverse and graph it. So these are the two types of scenarios you're going to be given. Now, this type problem is actually very easy. Kind of look up a picture here. See how it was right and then left? All we have to do is reverse these. So we just have to literally reverse the ordered pair. So we say -1, 1. And then we reverse the second one, 5, 2. You just go through the entire order, all the ordered pairs, and you just reverse them. Now, if you want to put this one first and reverse the list, you can. It won't make one bit of difference. So I usually just do them in the same order. So I'm going to reverse the third pair. I'm going to reverse the fourth pair, and I'm going to reverse the last pair. And that is the inverse. And in just a minute, we're going to do some graphing. So you're going to see how their graphs look. But right now, they just want you to get some ideas with ordered pairs. Now, this one is just in a table instead of ordered. So all we have to do is take this first set and reverse it. So we would do the output and the input. We just switch them. And then we switch the second, kind of like the X and the Y. And then we switch this one, the fourth one. Now the last one, notice they're both the same, so it looks the same. 3, 3, 3, 3, so that one looks the same. And we're done. So you should be able to fly through those type problems. It's just sometimes you forget what they want you to do. And sometimes we have a tendency to overthink these, like we think there should be more to do. But please don't make an inverse harder than it needs to be. All right, now we just have 4 problems down here. And if you don't have graph paper at home, it's not a big deal. I just want to be accurate on here. So that's the only reason why I put the graph paper. But if you don't have graph paper, it's no big deal. You can just sketch it. So we have to find the inverse and graph. It doesn't matter which one you do first. So I'm going to do the equation first here, and I'll do the graph first over here. So you can kind of see that it doesn't matter which one I start with, but if we were in class, I would ask you guys, but since we're not, I have to do it by myself here. So remember, this is actually a y. All I'm going to do is I'm going to switch my letters. Okay, so I'm going to switch just like it says up here, switching the input and the output. So I'm switching the letters. So I have an X, a Y, see how I switched them, and then the rest of it doesn't change. Once I have it switched, all I need to do is solve it for Y. So now I just need to get that Y alone. So I'm going to subtract 3, and so I have X minus 3 is equal to Y. And this is my inverse. Now, some of you might look at that and go, I don't want to go through all that work when I could have just switched the symbol. I agree with you. However, when you start throwing fractions out front, and if we were to do nonlinear, it would get a little bit more complicated. But in today's lesson, we're just going to stick with linear. So please try to go through this process of actually switching the letters because the concept is really important. Now, I'm going to graph this. So I'm going to graph this first one. So I'm going to put a little number 1 here. So that's the one I'm graphing first. So what I'm going to use is slope-intercept. Y equals mx plus b. So I'm going to start at 3 and put a dot. And then I'm going to go up 1 over 1, up 1 over 1. And I'm just going to do a couple even this way just so I have a good idea. And then, again, I don't have a ruler here, but I can use the side of this piece of paper. It's got a nice cardboard edge, so it kind of is nice and straight there. And there's my first one. And now I'm going to graph the second one here. So I'm going to graph the second one in red so you can see it. So same thing, slope-intercept. I'm going to start at -3. It's my intercept. And I'm going to do my slope of 1. So up 1 over 1. And if I want to go the other way, just to get a nice straight line, there's my inverse. Now, what I want you to notice, and this is a good way to always check your answer, is if you draw a line from corner to corner, so right down the middle as best you can. Now, I'm using a highlighter here, so hopefully the thickness won't throw me off too much. If I go right down the middle of my graph, so if I split my graph in half, are these 2 lines a perfect reflection? So if I were to fold my piece of paper over, so if I were to fold it over like this, would these 2 lines match up? And if these 2 lines match up, I know I've done it right. Okay? So that is how you do an inverse. Now, I told you on the second one, I'll start with the graph so that you can see it doesn't matter which one you do first. Sometimes people have a preference, but it really doesn't matter. They can be kind of independent of each other as well. So let me show you that. So if I use slope-intercept, this is going to start at 0. And then I'm going to go up 5 and then over 1. Remember, this is always over 1. Any whole number is always over 1. So up 5 over 1 and then up 5 over 1. Maybe just so I know, I'm going to go down 5 and over 1, just so I get a good idea of where this line is. And let me go ahead and connect them. Again, I'm trying to use a straight edge because sometimes I don't always connect the dots perfectly straight. So there's my first one. There's my original. Now, when I go to do the second one, I don't have a graph. I don't have an equation. How am I going to go for the second one? That's okay. Think back to what we did up here. Didn't we just switch the ordered pairs? So let me just make a little t-table. Just make a tiny little t-table right here. What are these ordered pairs? Well, this was 2, 10. 1, 5, 0, 0, that's this one, negative 1, negative 5. You see the ordered pairs? I can just reverse those. I can go 10, 2, 5, 1, 0, 0, I can't really reverse, negative 5, negative 1. And then I can connect them. And there's my inverse. Now look, and I won't use my straight edge, but if we were to connect corner to corner on this graph, and you were to fold this over, would they match up perfectly? And the answer is yes. So do you see how I didn't really need the equation? But if you feel more comfortable, you can easily do the equation first. It really does not make one bit of difference, okay? So let's cross this out and let's make this a y. Now remember, we're going to switch the letters only. So switch the letters, just the letters. Notice that's all I switched, it's just the letters. And now my goal is to get the y alone. So if I need to get the y alone, I would divide off the 5. So then on the right, I have y, and then most people would probably write this as 1/5 x, because now it's easier to do rise over run. So again, my intercept is a 0. I rise 1, I run 5. So up 1 over 5, up 1 over 5. And so now I know I've got it. So here's my inverse, and here's my graph. And those are the 3 parts to your answer. So these would be worth a lot of points if we were on a traditional quiz or test. Now, if you notice, the last 2 we have down here, and these are our last 2, have fractions involved. So if you want to try and pause it, you're more than welcome to. And I wish I was there with you, so I'll probably just do the same. I'll do the equation first on one and the graph first on the other, just so that you're kind of getting an idea of either way to do it. So what I'm going to do is I'm going to start by switching just my letters. So X and Y. So see, I just switched the letters. I didn't switch anything else except for the letters. And now my goal is to get this variable y alone. So I need to move the 2. Now be careful right here. If I was in class, I would ask you, what do you want me to do? And I hope you don't say divide by a half, because that's a compound fraction. How are you going to graph this? That would be extremely difficult to try to graph something like that, okay? So instead of dividing by a half, we're going to want to use the reciprocal. So we're going to want to multiply by 2 over 1. That way this half cancels. And so we have our y alone, and then we just need to make sure we multiply. So 2 times x, 2 times negative 2. And there's my inverse. So if we start by graphing the original, I'm just going to start at the 2. I always start at the intercept, and then I do my slope. Up 1 over 2, up 1 over 2, maybe down 1 over 2, just to, again, get a nice shape of this line. Sometimes if I don't do enough points, my line kind of looks a little crooked or something like that. So I just like it to be a nice straight line. So that's my first one. My second one, I'm going to go down to a -4. And notice my slope, remember, is always a fraction. It's always rise over run. So I'm going to go up 2 over 1. Up 2 over 1. Maybe even go down 2 over 1. Let me connect those. Now at first that might not look like it's a true reflection, but if I were to draw this diagonal in the best I can, notice it does split them. So you can see that it would get folded over this line. Okay, so I have done it correctly. All right, last one here. I told you I'd switch back and do the other procedure first. So in this one, if I start with the graph first, remember, it does not make a difference. It's a personal preference. So I'm going to start at the 4, and then I'm going to go down 2 because it's negative over 3. Down 2 over 1, 2, 3. And maybe let's just go 1 the other direction. Up 1, 2 over 1, 2, 3. And we'll connect those. Now, if you're doing the graph first, you might want to make yourself a little t-table because otherwise it can get kind of confusing with the ordered pairs. So I've got -3, 6. I've got 0, -4, 3, 2, and 6, 0. So I just kind of made a little table, and now I can reverse them. So 6, -3, -4, 0, 3, 2. Did I do? 'Cause my line isn't looking right, so give me 1 second here. So what happens when you're doing it live? 6, -3, -4, 0, 2, 3 would be there. So it's not going to make a line. I'm doing something wrong. 0, 6. I'm thinking it's this point right here. Oh, again, hopefully you would have caught this. Notice, see how I wrote 0, -4. That should have been a +4. That's why. I apologize. I wrote a negative, so this does not exist. So it should have been +4, 0. But that's good. I caught my own mistake. Hopefully if we were in class, you guys would all be telling me, no, that wasn't a negative. Okay, so I caught it. So I just reversed it. So 6, -3 is right here. 4, 0 is right there. 2, 3, so 2, 3, and 0, 6. It was just this point that was throwing me off. I wrote down a negative. One little negative throws my whole picture off. All right, and there's my inverse line. And if we were to go corner to corner, again, the best I can draw a straight line there. Notice if I were to fold them, this red would match with this one. And this blue would match with this one. So again, kind of just envision if you could take your paper and if you could just fold it straight over, would they match up? And then you know you've done it correctly. All right, and then now we're going to find the equation. So this is a y, and we're just going to switch the letters. So again, just the letters. So see, that's the only thing I changed was the letters. And now we're going to work to get this y alone. So we're going to move everything to the other side. So we're going to start by moving the 4. And then I would use the reciprocal again. So this time we're going to multiply by 3 over -2. So on this side, it's going to be 3 over -2. So this will cancel, and that's how you'll get the y alone. And then you just have to distribute. I usually, when I write my fractions, I do like my negative usually on top. So I would probably write it like that. Just put the negative on top. And then notice a negative times a negative would be a positive. 3 times 4 is 12. 12 divided by 2 is 6. So here's my inverse. Now let's just quick check this. This is the red line. Are we at 6? And are we going down 3 over 2? So from here, down 1, 2, 3 over 2. Down 1, 2, 3 over 2. So we know we've done it correctly. So again, I just wanted you to see that it does not matter which one you start with. You can start with the equation or you can start with the graph. If you start with the graph, the only thing you might need to add extra is this tiny little t-table. All right, class, I'm proud of you. This concludes Chapter 10, and this concludes Algebra B.